So hello friends, welcome back to my channel. So in my last video, I was explaining 12th standard physics question paper 2022 I was solving. So it is Karnataka board paper. So let us come to the question now. So it is part 2 video. In first part I have solved 11 questions of first main, 10 marks questions, 1 mark question, 11 questions I have solved. Means 12 questions I have solved. So let us continue now. 13th one. What is meant by the ionization energy of an atom? What is an ionization energy of an atom? They have asked. So, ionization energy of an atom. So, it is the energy. It is the energy that is required. Energy that is required. It is the energy that is required to remove. It is the energy that is required to remove an electron from an atom from its ground state. So, removing the elements from an atom from its ground state is known as ionization energy of an atom. So, question number 13 is. Moving on to question number 14, here they have asked, give an example for elimination semiconductor. What is it? So, one example they asked, so I am giving here two, that is silicon, and another one is germanium. So, two example I am giving here. So, question number 14 is done. Moving on to question number 15, here they have asked us to draw logic symbol of NOT gate. So NOT gate logic symbol to draw that they have asked. Okay, so this is the logic symbol of NOT gate. So question number 15 is done. So by this one more question, all questions are done. So all one more questions we have completed. Now let us move on to part B. That is 2 more questions. Here they are asked to attend any 5 for you. So let me solve all the questions here. So second main part B. It is part B. Second main. 16th one, what are polar and non-polar molecules? They have asked. What are polar and non-polar molecules? They have asked. First let us read polar. Polar molecules. So these are the molecules. These are the molecules in which the centers. These are the molecules in which the centers of positive and negative charges, the center of positive and negative charges do not coincide. Okay, this is polar. Non-polar molecule. These are the molecules in which these are the molecules in which the centers of positive and negative charges, the center of positive and negative charges coincide. Okay, so this is polar and non-polar. Okay, question number 16 is done. Question number 17. Here they have asked us to show with the schematic graphs variation of resistivity with absolute temperature for nichrome and silicon. Okay, this they have asked. So now we have to write graph here. So let us come to next question number 17. So this is, let us take it as 1.10. This is 1.20. Here 200. Here 400. Here 600. Here 800. Okay, from here it starts. Okay, like this it will be. So temperature this side, T of K, and this is the resistivity. P of mu ohm, centimeter. So first one is done, nichrome we have done. So this is how the graph will be for nichrome. Next let us make for second one that they have asked, that is for silicon. This is first one. This is pressure, this is temperature. So it will be like in this method falling. Okay, T. So this is the silicon, this is nichrome graph, resistivity and absolute temperature and resistivity. So question number 17 is done. Now let us move on to our next question. In question number 18, they have asked us the current in a coil falls from 25 milliampere to 0 milliampere in 1 meter per second, and induces an electromagnetic field of 10 volt in it. So we have to find the self-induction of the coil. So the things that they are given is here. Question number 18. Let us write given. That is 10 volt. That is the induces an EMF of the coil. Then dt, that is equal to 25 milliampere. It will be 25 milliampere only. Minus 0 if we do also. Then and dt is equal to 1 meter per second. So for calculating the self-inductance or L of the coil is equal to L. L we have to calculate Tt, TL by Tt is TL. This is also TL. That is equal to 10 is equal to L into 25 by 1. That is equal to L is equal to 10 by 25. That is equal to 0.48 is the 0.48 is the self-inductance of the coil. So question number 18 is done. So moving on to our next question, that is question number 19. Here they are asked to give the working principle of AC generator. Why the current generated by it is called alternating current. So AC current, it works on the principle. It works on principle of EMI, electromagnetic induction, as the rotation of the coil continues. Hence induced potential difference reverses the direction. Hence induced current constantly changes. So this is the answer for question number 90. Okay, next question number 20. They asked what is displacement current and write its expression. So displacement current, so the current due to time varying electric field is called displacement current, and its expression is equal to E naught A dE by dt, or ID is equal to E naught E by dt. So this is the formula for displacement current. So this is the explanation of displacement current and expression. Question number 20 is done. So moving on to the question number 21. Here they have asked us to give reason for these following statements that they have given. The first statement that they have given is the sun is visible a light before the actual sunrise and until a light after the actual sunset. So this is why they are asking. So it is, so first one, right? So it is due to the Atmospheric refraction. Due to atmospheric refraction of light. Due to the atmospheric refraction of light, the sun is visible a light before the actual sunrise and until a light after the actual sunset. Then question number 21 part sub question B, they are asked, the sky appears blue. So this happens because of scattering of light. Due to scattering of light, our sky it appears as blue to us. So by this question number 21 is done. So moving on to our next question, that is question number 22. Here they have asked us to write any two uses of Polaroids. So let us write the two uses of Polaroids. So the first one that for which the Polaroids are used, it is in sunglass. The Polaroids are used sunglasses, in the window panes, in the automobiles, 3D movies, and in many other things they are used. The second point is they are used in microscopes, for microscopes, in camera, LCD, calculators, and many other things they are used. In many other things they are used. So question number 22 is done. Now, so if we move on to our next question, that is question number 23. Here they have asked us what are de Broglie waves and name an experiment which verified the wave nature of electrons. This is the question they have asked. So the waves that associated with the moving material particles are called matter waves. It is called as matter waves or de Broglie waves. And the experiment which verified the wave of natural of electrons is the Davison. It is the Davison's German experiment on the nature of the electron. So this experiment helps us to verify the wave of electrons, nature of electrons. Next, so question number 24 is done. So moving on to our next question, that is question number 24. 23 is done, so question number 24, let us move. So here they have asked us to draw the label diagram representing the schematic arrangement of Giger-Marsden experiment for alpha particle scattering. So, okay, so here let us start. two poles. So here you are making two poles. Okay. So this is the source of particle. Here this is the source of particle. It is lead bricks. Now this particle moves on here. Okay. So it is the beam of a particle. So that particle that is out, it is the beam of the particle. That particle that is beam. Next here. Okay, here one. That is, this is the gold foil. Okay. So here, so this is large angle scattering of some particles. So this is backward scattering of a small, very small fraction then after this here let us make it like this only. Okay, this is the small angle scattering of zone. Then here it is ZNS screen. So let us bring this till here. Okay, here it is angle is theta. here online. Then it is detector or microscope. Okay, so this is the diagram of the Giger-Madsen experiment for alpha particle scattering. Okay, so this is how you have to try if they ask in your next exam. So question number 24 is done. Okay, so now let us move on to our next question, that is question number 25. Here they have asked, give any two advantage of LEDs over conventional incandescent low power lamps. The first one is the energy efficiency. The second advantage is it is long life. And the third one is, let us write 3. They asked 2, but let us write 3. It is high brightness and intensity, and many are there options. Many other advantages are also there. So they asked only 2, so I have written one extra 3 also. We can write. So question number 25 is done. So by this, all part B question are done. Now all part B questions are done. So now we have to move to our next part, that is part C questions. Third main 26th one, part C question. So in part C, first question they have asked that to mention the 3 factors on which the capacitance of a dielectric parallel plate capacitor depends. This is the question they asked. So let us write the 3 factors now. So first factor, on area of the plates, is the area of plates. The second factor that on which it depends is the distance between the plates. Distance between the plates. And the third factor is dielectric medium between the plates. Dielectric medium between the plates. So on these factors, the capacitance of a dielectric parallel plate capacitor depends. So question number 26 is done. Now next question number 27. So here they have asked us to derive the expression for the drift velocity of electrons in a conductor in terms of their relaxation time. Okay. drift velocity expression they have asked us to draw. So let us draw it. So here lines are connected me here on center. Then here let us draw one line from here to here, here to here. Here another one point. Here another one. So here, okay. Battery it is. And the second point here it is connected to another end of the battery. Okay. This is E. This is VD. 2 points VD. E minus. This is V into L. Okay. So these are the points. So this is the expression for the drift velocity of electrons in which conductor in terms of their relaxation time. And here minus also it will be. Okay, so question number 27 is done. Now moving on to our next question, that is question number 28. Here they have asked us to write the two reasons to show that the galvanometer has so now they have asked us to write expression also, right? So here only I have written the diagram. So let us write the expression. First expression is E is equal to V by L. This is the first expression. Then second equation, A is equal to F by M. That is equal to minus E by M. This is the equation 2. Okay. Then after this, that is here only, right? V T is equal to U plus AT. That is equal to 0 plus E by M into T. So therefore here Vd is equal to by M into T. So therefore finally we'll get as, that is Vt is equal to Ve by Lm into T. So this is the final formula, final expression that we get, where E is equal to V by L we have taken. Okay, so this is the final formula we get after writing this expression. So now let us move on to the next question, that is question number 28. So here they are asking us to write any two reasons to show that the galvanometer as such cannot be used as ammeter, and we have to give the method of converting the galvanometer into an ammeter also. Okay, so Method of converting the gallon-meter into ammeter. So conversion of gallon-meter into ammeter. So here, so conversion of galvanometer into ammeter. So here ammeter is an instrument used to measure. Ammeter is an instrument that is used to measure current. That it is current. It is used to measure current. It is always connected in series. Ammeter is always connected in series in a circuit. In a circuit, the ammeter is connected always in a series in a circuit. After including the ammeter in the circuit, the current should not change. Hence, the current it must have a low resistance. The resistance of galvanometer, the resistance of galvanometer should the resistance of galvanometer should be made negligible negligibly small by connecting the a low resistance in parallel, a low resistance in parallel with the coil. So the moving coil galvanometer with this modification, it is called as the ammeter. Now, so let us draw its how it is becomes ammeter. So here on let's take it as galvanometer G I. Then here also another point, that is here also I, that is current, and here IG. I minus IG. This is S. So this is the circuit diagram of converting the Gallon meter into an ammeter. Okay. After this, here G that we are given, it is the resistance of the Gallon meter. G is the resistance of a galvanometer. The S that we have mentioned here, it is the shunt resistance or a low resistance that is connected in parallel with the coil. So as we said here, the resistance of a galvanometer should be made negligible, small, by connecting a low resistance parallel with a coil. So this is the resistance that we have connected here. Next, I, that is I here is the formula I minus Ig. Here I is the main current, Ig is the current required to produce full scale required to produce full scale deflection, and here I minus Ig, it is the current through S. Since here, so the formula will be I minus Ig into S, that is equal to Igg, where S is equal to Ig by I minus Ig into G. This is the formula after converting gallon meter into an ammeter. So question number 28 is done. Now moving on to our next question, that is question number 29. Here they have asked us to list any three properties of ferromagnetic substances. They have asked us to list any three properties of ferromagnetic substances. 29th one. So the first one is of ferromagnetic materials. Ferromagnetic materials get strongly magnetized. Ferromagnetic material, it gets strongly magnetized when it is placed in an external magnetic field. The second property is ferromagnetic materials have strong tendency to move from a region of weak magnetic field to a region of strong magnetic field. Next, third one, ferromagnetic materials are strongly attracted by magnet. So let us rate 1 or 2 points more. Fourth one. So it is relative permeability of a ferromagnetic material is very low. It is very low. And thus susceptibility susceptibility of a ferromagnetic material decreases with increase in temperature. So question number 29 is done. So moving on to our next question, that is question number 30. Here they have asked, write any three applications in which advantage of eddy current are used. So the first one is, it is a eddy current. It is used for magnetic. It is used for magnetic break, braking in trains. In trains that we use magnetic brakes, in that eddy current, in that it is used. Then second one, electromagnetic dumping, also it is used. Electromagnetic dumping. Third one, it is used for induction furnace. And fourth one, it is used for electric power meters. So for these, the eddy current are used for this. It gives advantage. So the question number 30 is done. Moving to question number 31. Here they have asked, mention any three sources of energy loss in an actual transformer. So the first one is three only there, that is copper loss or copper losses. Second one is the loss due to flux leakage. Loss due to flux leakage. Loss due to eddy current. So these are the losses from where the energy is lost in an transformer. So question number 31 is done. Now moving on to our next question, that is question number 32. Here they have asked, using a Hughes principle HT, show that the angle of incident is equal to the angle of reflection when a plane wavefront is reflected by a plane surface. So first let us draw it. So question number 32, right? Let us put it here first. Reflection, let us show here. Okay. Let us make one point here. It is a another one here, it is C, and here let us make this reflection angle, it will be, that is the P1, and this is B. Okay, here it is D, here reflection, or here it is I, and here it is N, and it is N dash, and here is the reflection that it is coming. Okay, here also, and here also. Okay, so this is the how reflection happens, that diagram. And here xy is the plane reflecting surfaces. Here this xy plane reflecting surfaces, and v is the velocity of light, and ab is the incident wavefront, and cd is the reflected plane wavefront, I is the angle of incident or incidence, and r is the angle of reflection. Then now if we come to the equation that they have asked now, so let us write it. So these all things for your understanding I have written. If you want, you can write in this your exam also, or you can write the formula that they asked to find. BC by T, that is equal to BC equal to VT, equation 1. Here V is equal to AD by T, that is equal to AD is equal to VD. This is equation 2. So in triangle ABC and triangle ADC, so here AD and BC we will get, so AD is equal to BC, that is equation 3. Here AC is common. If we write another one, that is angle ABC, that is equal to angle ADC. Here AC is common, AD is equal to BC is the thing we will get. So then angle angle BAC is equal to TCA, I is equal to R will get, that is the fourth equation we get. So by this, angle of incident is equal to the angle of reflection, we can say. So by this 32 question is done. Next 33rd question that they are asked is to The third question they have asked is to write the three postulates. We have to write three postulates of Bohr model of hydrogen atom. First postulate is, so it states that an electron in an atom could resolve or revolve in a certain stable orbits. In certain stable orbits, it can revolve without the emission of radiant energy. According to this postulate, each elements or each elements, or we can say atoms, has certain definite stable orbits. Certain definite stable orbits in which it can exist and in which they can exist and each possible state has definite total energy. These can be called as stationary states of an atom. So this is the first postulate. Second one. In second postulate, it states that the electrons revolve around the nucleus only in those orbits for which the angular momentum is some integral multiple of h by 2 pi. So it states that in second postulate, the electron that revolves around the nucleus only in those orbits for which the angular momentum is some integral multiple of h by 2 pi. Third postulate, we can say that the third postulate, it states that electrons might make the transition from one of its specified non-radiant orbits to another of lower energy. So the third one is the third postulate, it states that an electron might make the transition from one of its specified non-radiating orbit to another of low energy or lower energy. So these are the postulates you can write. Question number 33 is done. Now moving on to the next question, that is question number 34. Here they are asked, define mass defect and binary energy of a nucleus. They asked us to define mass defect and binary energy of a nucleus and write the relationship between them. What are the relationship between them we have to write. So mass defect, first let us write mass defect. So mass defect, this is the difference in mass of a nucleus and its constituents. The difference between mass of a nucleus and its constituents is called mass defect. And binary energy or nuclear binding energy, the binding energy or nuclear binding energy, so it is the binding energy of a nucleus. The binding energy of nucleus is defined as the minimum energy that is required to split the nucleus. That is the minimum energy that is required to split the nucleus into its constituent nucleons. And the relationship between them. So here let us take MP as the mass of the so relationship is mass defect is equal to total mass of the nucleon minus mass of the nucleus. That is delta M is equal to ZMP plus A minus Z Mn minus M. This is the formula. Here ZMP, Z is the atomic mass and MP is the mass of the proton plus A is the mass or mass number. A minus Z is the number of neutrons and Mn is the mass of neutrons minus M is the mass of nucleus. So question number 34 is done. Now moving on to our next question, that is question number 35. Here they are asked to write difference between intrinsic semiconductor and extrinsic semiconductors. So intrinsic semiconductor, so it is semiconductor that is in it is semiconductor in pure form. It is semiconductor topped with a impurity. And intrinsic semiconductor, so the electron density and hole density are equal, and hole density are equal. Electron density and hole density are not equal. And the electrical conductivity is low in intrinsic. The electrical conductivity is low. Electrical conductivity is high. Okay, so these are the difference between intrinsic semiconductor and extrinsic semiconductor. Sorry. Okay, so 35 A question is done. So by this, all part C question is done. So next part D, and we have the numerical questions here. So I think we can solve it in my next video. So till here it is enough, I think. So okay friends, in my next video solving, continuing this question paper by finishing this question paper in next video. So till then, take care, have a nice day. Bye my dear friends.